If you are building software right now, you can probably feel the ground shifting under your feet. The AI front-end world isn't just moving fast, it's undergoing a profound transformation. Today, we are doing a deep dive into that transformation, generative UI.
And this is a really important distinction to make right up front. We're not just talking about a large language model spitting out a block of text that you then have to, manually format.
No, not at all. This is AI taking full application ownership. We're talking about agents dynamically creating rich, interactive interfaces on the fly, sophisticated financial forms, complex data visualizations.
Entire application workflows that adapt based on the conversation you're having with the AI.
Exactly. This generative UI shift is truly the aha moment for developers.
Yeah.
We found some industry analysis that actually called this the most significant evolution in front-end development since the rise of React.
And it really is. The core idea is surprisingly simple when you boil it down. You're just connecting the results of an AI tool call directly to the structured, reusable React component.
Right. We're moving from static pre-built apps to these fluid AI-driven experiences. So our mission today is to cut through all the noise. We've reviewed the comprehensive source material that maps this whole landscape as of, January 2026. We're going to compare the leading frameworks, dissect the new protocols, and critically highlight the major security risks you absolutely have to anticipate. You really need this knowledge to navigate the next 12 months in development.
Yeah, let's unpack this and maybe start with the timeline.
Yeah. The timeline is crucial because you have to appreciate the speed here. Vercel only coined the term generative UI with v0.dev back in October 2023, and that felt like science fiction at the time.
It really did.
And now just look at the standardization curve. The foundational shift really happened in late 2024. Anthropic released the Model Context Protocol, or MCP, in November 2024.
And that was the game changer. It established that common language for agents to describe the tools they want to call, the data they need. Exactly. And once MCP was out, the whole ecosystem had to react. OpenAI officially adopted it just 4 months later, in March 2025. That rapid adoption signaled that this wasn't just some fun feature, it was becoming the standard for how agents communicate.
And the governance followed pretty quickly after that. By December 2025, we saw Google launch A2UI, and maybe most importantly, the establishment of the Agentic AI Foundation.
Right, co-founded by OpenAI, Anthropic, and Block, all under the Linux Foundation banner, specifically to govern these new open standards.
That timeline is just... It's exhausting. It shows how fast these foundational standards are being set, and that's where the protocols come in. You mentioned MCP, but the sources show we now have 3 complementary layers. They form what people are calling the Modern Agentic Stack, and they each have very distinct roles. So first we have MCP, the Model Context Protocol, which you said is the core. It's the agent's brain, right? The tools and the data integration. It's the decision maker. Then you've got A2UI, the Agent User Interaction Protocol, which was pioneered by CopilotKit. And this is that crucial runtime layer, the active bridge between the agent and the front end.
It manages the real-time state, making sure the agent and the user are always in sync.
Right. And then finally, the new kid on the block, A2UI from Google, which is purely a declarative UI spec. It doesn't handle the complex real-time connection like AGUI does. Its job is just to define the structure of the interface.
Like saying, I need a form with 3 fields and a submit button.
Exactly.
If we connect this to the bigger picture and maybe use an analogy, it becomes a lot clearer why they're complementary and not, competing. Think of it like a restaurant order. MCP is the chef. It decides what tools or ingredients to use and the steps to prepare the meal based on your request.
Got it. The decision maker.
Then A2UI is the blueprint for the plate. It's the declarative design. It just says the steak goes here, the mashed potatoes go there, and the button or garnish is in the corner. It describes the final look, whether you're serving it on a web plate or a mobile one.
Okay, so it's just the layout.
And finally, AGUI is the waiter. It's the runtime layer that's actively carrying the meal, the real-time updates and state from the kitchen, the agent, directly to your table, the front end. A modern agent uses all 3 to create a seamless experience.
That analogy makes it click instantly. Okay, so now that we understand the foundations, let's look at the actual frameworks that let you build this stuff today. We've got a few clear leaders, and each one seems optimized for a specific use case.
Right.
Let's look at CopilotKit first. Based on the metrics we've seen, is it fair to say it's become the de facto React standard for in-app agents?
Oh, absolutely. It's the most mature open source option for deep integration. I mean, it's proven by its, 22,300 plus GitHub stars, and the adoption is enterprise grade. We're talking over 10% of Fortune 500 companies trusting it for their internal tools.
So what's the secret sauce? Why does it dominate that deep integration space?
It's the features. They didn't just build a simple wrapper, they built a real agentic framework. Two concepts really stand out: co-agents and context sharing.
Co-agents.
Yep.
That's the multi-agent orchestration, right?
Exactly. You aren't stuck with one big do-it-all AI. You can orchestrate smaller, specialized agents to handle different parts of a complex workflow. And context sharing, especially with things like Use Copilot Readable, is a game changer. It ensures the AI agent knows exactly what the user is currently looking at on the screen.
Which improves relevance and interaction quality immensely. That's powerful. Orchestration and screen awareness are huge. But then you have the Vercel AI SDK, which it just seems to win on sheer volume and flexibility. We're talking over 20 million monthly downloads.
It's the streaming engine, pure and simple. It's designed to be streaming first. That guarantees that fast, real-time token experience that users now expect from any AI interface.
And it's provider-agnostic.
Completely. You get a single, unified API across more than 50 LLM providers, so whether you're using a big vendor or a small open-source model, it just works. It gives you flexibility and prevents that vendor lock-in, which is a massive deal for startups.
But wait, I have to challenge this point. If generative UI is the future, our sources noted that Vercel has paused development on their AI SDK RSC components, their React server components. Doesn't that make Vercel fundamentally less future-proof than a full-stack, server-centric solution like CopilotKit?
That's a really critical point, and you're right to bring it up. The pause on RSC development, I think, it signals a maturity in the field. Vercel's current recommendation is firmly to use the client-side use chat hook with tool invocations for generative UI.
So they're steering people away from server-side UI generation for now.
For now, yeah. It seems the complexity and overhead of managing it purely through server components is a performance bottleneck they want to avoid, which is a huge strategic insight. They're prioritizing performance over a specific feature set right now.
Understood. So if you prioritize flexibility and sheer speed, AI SDK is the standard, but you're working client-side. Yeah, let's look beyond the web.
And that's exactly where Google's A2UI is positioned to dominate. They saw the problem. Web frameworks don't translate easily to native mobile or desktop experiences. A2UI solves this with a declarative JSON format. The agent returns that JSON, and the host app, whether it's running in Lit, Flutter, Angular, whatever, renders it natively.
So what's the key takeaway there?
Its core philosophy is security first. A2UI agents can only request components from a pre-approved, host-defined catalog. And that inherent security, combined with native rendering, means you avoid the performance cost of sandboxed iframes, which is the security compromise other protocols have to make.
So for large enterprises with strict security policies?
It's the obvious choice, especially if they need a unified cross-platform experience.
Okay, so even if you're building all this agentic power, you still need a high-quality front end to host it in. That brings us to Assistant GUI. This is the library that's dominating the chat component market. 50,000 monthly downloads.
It's popular because it just nails the developer experience. It gives you these highly composable primitives, think Radix style, instead of one big monolithic chat box. It comes production ready for all the hard stuff: streaming, handling retries, markdown rendering. If you're using a complex agent orchestrator like LangGraph or the Vercel AI SDK, Assistant GUI is just the fastest way to wrap a polished UI around it.
And the high-value use cases are really starting to validate this whole movement. When we talk about LangGraph for agent orchestration, we have to focus on the results. Uber is using it for their internal AI developer tools. And the payoff isn't theoretical. They saved their 5,000 engineers 21,000 developer hours.
That is not a marginal improvement.
No, it's a radical, immediate ROI.
And LinkedIn is doing the same thing with its AI hiring agent, automating huge parts of the recruiter workflow.
Oh.
These numbers, these 21,000 hours, they validate the entire thesis of generative UI, that agents can handle complex, multi-step tasks better than humans clicking through forms.
And speaking of forms and data, we also noted Thesys Crayon. Their C1 API is fascinating because it's a drop-in LLM replacement. You just change your endpoint, and instead of text, you get structured UI components for data vis.
It just shows the future isn't only about agent orchestration, but also about these purpose-built APIs that completely bypass the text-to-UI translation step. It makes dashboard prototyping basically instant.
Incredible power. But looking at those massive time savings and the deep access these agents have to corporate data, that success immediately makes me nervous. We have to talk about the elephant in the room: security.
Exactly. When agents have the power to dynamically generate interfaces and execute tool calls, and sometimes they're doing that based on user input, the security stakes just increase exponentially.
So where do we start?
We should anchor this on security expert Simon Willison's concept, the lethal trifecta. This is the perfect storm for a prompt injection attack. You're vulnerable if your agent has all three things. 1, access to private data. 2, exposure to malicious instructions. And 3, the ability to exfiltrate that information.
And if you hit that trifecta,
you're facing a catastrophic data leak. And we saw this play out vividly in 2025 around the MCP protocol. The first big one was NeighborJack.
NeighborJack, right.
And that was just pure operational negligence. Hundreds of servers running MCP were incorrectly bound to 0.0.0, so they were exposed to the whole local network, not just local host. A malicious employee, an intruder, they could just send commands to the agent and compromise data.
Then you had the sneaky attacks, the ones users don't see coming. Tool poisoning. That's so insidious. Malicious instructions are hidden invisibly inside the tool descriptions. The user never sees them.
But the LLM does. And when it reads the description to decide whether to call the tool, it executes the hidden prompt and often leaks data.
And the one that scares me the most was the rug pull vulnerability.
Oh, that one is frightening. Imagine you're a developer, you install a new tool for your agent, you check the source code, you approve it on Monday, it's safe. But by Friday, a bad actor has mutated the underlying tool definition, changed its code or permissions. And now, when the agent calls that tool that was already approved,
it exfiltrates data, and you never got a notification because you already trusted it.
It requires constant active monitoring of your tool definitions. It completely shifts the paradigm.
Okay, so let's make this actionable for the developer who's listening right now. What are the mandatory, non-negotiable best practices?
Number 1. If you can possibly avoid it, do not generate raw HTML, CSS, or JavaScript at runtime.
Use declarative UI frameworks like A2UI.
Exactly. It's the simplest fix for the lethal trifecta because by restricting the AI to a pre-vetted component catalog, you fundamentally remove its ability to generate malicious code for exfiltration.
2. Human in the loop.
Always. It is non-negotiable for sensitive actions. If the agent wants to delete a database entry or process a payment, those built-in approval workflows, which frameworks like CopilotKit offer, must require a user to click a button.
And operationally, tying back to NeighborJack, never ever bind your MCP servers to 0.0.0.0 in production. Stick to local host only in dev, and you have to monitor for those tool definition mutations to prevent rug pulls.
The industry recognized that developers needed a centralized, more secure approach. And that led to the emerging standard. MCP Apps, or SF 1865, this is the unified standard coming out of Anthropic and OpenAI for interactive UIs directly inside the Model Context Protocol.
So how does it improve security?
It uses 2 key mechanisms. First, the UI is placed in sandboxed iframes, so even if malicious code gets generated, it can't access the host application's DOM. And second, it requires pre-declared templates. The developer has to define the UI template beforehand, so the host can audit the structure before the agent even populates it with data.
It introduces that iframe isolation cost we talked about, but it provides a much safer harbor for tool UIs.
A unified, auditable, and much safer harbor.
Yeah. Okay, let's tie this all into a clear decision matrix for you, the listener, based on your current needs. If you need granular control, deep multi-agent orchestration with co-agents, and that seamless context awareness inside an existing React app,
you go with CopilotKit. It's the most mature choice.
Right. Now, if you need immense provider flexibility, you need to swap between 50 different LLMs, and maximizing low-latency streaming is your top priority.
The Vercel AI SDK is the industry standard toolkit. Just remember to stick to client-side tool invocation.
And finally, if your mandate is strict security, cross-platform parity across web, mobile, and desktop, and you prefer the safety of declarative component catalogs,
Google A2UI is your foundational choice, no question.
And what's fascinating here is that the optimal strategy isn't just picking one.
Not at all. These are best viewed as complementary layers. The most robust and secure application will probably blend these standards. You might use CopilotKit for the AGUI runtime connection and agent logic, but leverage A2UI's declarative spec to make sure the UI components render natively and safely on every platform. The ability to mix and match is the key skill for 2026.
And I think that leads us to our final thought. While we've covered the technical frameworks and protocols, the biggest thing to watch for the rest of this year is the Agentic AI Foundation itself.
I completely agree. Founded by OpenAI, Anthropic, and Block, housed under the Linux Foundation. This organization has a new mandate to govern open standards like MCP and A2UI. The convergence, the security standardization, the adoption criteria they drive, that will ultimately dictate the speed and, more importantly, the safety of generative UI adoption globally. Watch their quarterly reports. Their decisions will shape this entire developer landscape more than any single framework release will this year.